Hi, everyone. Thank you for joining us for Cota Access. My name is Albert Azud. I'm a partner at Cota Capital. Cota Access is a recurring webinar series that we host several times per year, where we bring together founders, thought leaders, and leading executives to explore a variety of business and technology trends that are impacting large enterprises. For those of you who do not yet know us, Cota Capital is an SEC-registered multi-stage firm based in San Francisco. We focus on US-based modern enterprise tech companies, and we've invested in over 75 private and 25 public companies since the inception of the firm in 2015. Our focus is on companies that are innovating across infrastructure, workflow automation, applications, as well as on several verticals, including fintech and life sciences. We're always looking for passionate founders and transformative companies. We welcome the opportunity to meet you, so please reach out to us. You can reach me personally at albert@cotacapital.com. I'll now let our operating partner, Simone, kick off today's Cota Access and introduce you to our panelists. Thank you very much.
Thank you very much, Albert. And panelists, online attendees, welcome to Cota Access. As Albert was saying, this is a regular series of events covering technology and entrepreneurship. The purpose of having experts and industry leaders is to foster a discussion that gives you, the audience, useful information and that makes complex technical details easier to understand and digest. So some quick housekeeping. I'm Simone Brunozzi, operating partner at Cota Capital. I'm your host today. This event will last for 60 minutes. So it will end at 11 a.m. Pacific time. The event is recorded, so it will be made available afterwards. So do not worry if you're missing something. You can always watch it later, and you can share it later as well. Number 4, you can ask questions on Zoom, and we will pick 1 or 2 of these questions during the event. That's it. That's it for the housekeeping. Now, even before I introduce you to these amazing 4 panelists, let's get things going with a provocative question. And the question is the following. Is 5G really revolutionary, or should we have called it simply 4.1G? So what's special about it? Sebastian, go ahead.
Yeah, well, from what we have seen, every 10 years or so, right, starting with 1G and the analog network that was first introduced in Japan to in 1979 to the 2G network that was introduced in Finland in 1991, that it takes about 10 years or so for big step function changes in mobile networks. And what happens is that we see significant improvements and new capabilities. And I would say that 5G is no different here, right? But the devil's in the details, and I'm looking forward to be discussing those. That said, I should probably kick it over to my other panelists here because they have some very good insight in regards to what those are.
So 5G opens up frequencies and large bandwidth in the spectrum that has not been used before. Why? Because we need large bandwidth to support large data, and we need reliable and fast communications. And it's really time to, as we do every 10 years, to step up the game. The combination of massive bandwidth and ultra low latency opens door to revolutionary applications that have not been even imagined before.
So just to add to what Sebastian and Mariam had to say, yes, every 10 years or so is when the technology changes. When we started calling it 1G, actually after we did 2G and 3G. I think when we were in 1G, we didn't know we were in 1G, right? So every G has brought many more capabilities when we look back at the last 30 plus 40 years of wireless technology. So 5G, I mean, so when the standards implements a new type of technology, it is based on the learnings of the previous generations of technology, right? Whether there are shortcomings of the previous technology and you kind of try to overcome them in the next generation. And absolutely 5G has taken 4G to a next level. Just like Mariam said, not only at low frequencies can we build networks. Now we are talking about building networks at higher frequencies, which was much more harder thanks to some of the technologies that companies like Mariam's are building, making it possible for that millimeter wave to be harvested. It's really real estate and spectrum that can be harvested for use in applications where we see the need for more bandwidth. In addition to that, 5G also, the network architecture is different for 5G than it was for 4G or 3G, because we've realized as a technology industry the need to reduce the latency in our networks, and there are many more applications that can be enabled. IoT has driven applications, the characteristics of 5G. So 5G takes 4G into many more different directions, and improves on many different features that I say it is very different and significantly better.
Thank you, Sanjogita. Verban?
So is 5G revolutionary? I would say, both yes and no. It's along the lines of what Sanjogita said, right? I think the vision for 5G is amazing, right? It's a whole new architecture, the millimeter wave stuff, and including the lower part of the frequency all combined together in one protocol. That's amazing, right? And the promise of it is amazing. But, just like what Sebastian said, right? The 10-year timeline, you have, as it is with any trend, right? The early part of it is going to be questioned. It's going to be difficult to deploy, right? The technical challenges there, the technology is required to enable it. But once you are on the later part of that trend, right? The last 3 years of the 10-year period is when all of us gonna be here and celebrating 5G, I think.
Nice. Thank you, panelists, for your answers. Now I think it is time to properly introduce you to the audience, but I do not want to steal your thunder, so I will let you introduce yourself, who you are, your background, and a very quick intro of your company. Go ahead, start with Mariam.
I am co-founder and co-CEO of Movandi Corporation. Before Movandi, I was Senior Vice President of Engineering at Broadcom, responsible for development of all the wireless radio products. And before that, my brother and I had a startup called Invent Systems, where we pioneered and developed the first CMOS, Bluetooth, and Wi-Fi SoCs. We sold Innovent to Broadcom in 2000, and that's how Broadcom got into wireless business and grew it from no revenue to shipping more than billions of radios per year. Movandi is solving the technical challenges of 5G millimeter wave. Our BMXR is the industry's first smart active repeater solution that improves coverage, extended coverage of 5G millimeter waves, and helps to significantly reduce deployment costs. It's designed to penetrate the barriers and amplify millimeter wave coverage outside and inside buildings, and enabling leading carriers like Verizon to expand 5G networks. Our core technology includes integrated circuits, antennas, systems, and algorithms that improve performance, coverage, and latency to enable 5G.
Hi, I'm Veerpan. I'm from Quadric. You can probably see the logo here. I've come from Carnegie Mellon, have a doctorate from there. I've been through the pains and gains of 2 other startups before Quadric. One of them was in cryptocurrency space, so Bitcoin, and the other one was in CAD software space, so very different spaces. But the most interesting of the 3 startups is definitely Quadric. So three years ago, me and my co-founders, we came together and we bet on this trend, which was we recognized how difficult it was to do data processing at the edge. No good platform existed. We tried a bunch of applications and we realized this is going to be important. As many more devices come online, compute is going to have to move away from the data center and come closer to these devices. It's just impossible to get the entire compute done in the cloud. And I'm super excited about 5G because it exactly accelerates that trend. It connects a lot more devices. And that's what the platform we built at Quadric, it exactly optimized to fill into that need. So super excited to be here. And looking forward to what 5G brings.
Thanks, Verband. Sebastian?
Yeah, hello, everybody. My name is Sebastian. I'm originally from Munich, Germany. And then after college, I decided to come to the US West Coast and join a friend of mine in a tech startup. And a few tech startups later, and a couple of pains and gains later, and certainly a few scars, I had an opportunity to join AWS in Seattle. And since the last two startups I worked with, one of the more prominent ones was an enterprise search company, were built on top of AWS. I thought that is a really interesting opportunity. And I want to enable other startups, just like AWS enabled us, to innovate and build new things and really change whatever their market is, their target market is. And worked here for a couple of years in what we call the go-to-market team. Worked very close with our service, product management, and engineering teams, as well as our field teams that educate our customers on different services, the go-to-market strategy, the use cases, the economics of a service. After a few years, I decided to actually go back to the startup world and joined a startup that built an evolved packet core, a 4G but CUPS architecture evolved packet core on top of AWS, enabling basically MVNOs or even telcos to leverage AWS and cloud infrastructure to build a mobile network, or at least the core of a mobile network. And after that company got acquired by KDDI, a Japanese telco, I decided to maybe go back to AWS. And I didn't actually know what I wanted to do there yet. And reaching out to a few old friends of mine, they said there might be an opportunity where you can marry some of those experiences. They didn't tell me anything about the job, but it was about edge compute. And I thought, why not? So I joined a few weeks later. I actually found out it was about wavelength. That was January last year. We announced wavelength in November or December last year. And actually now launched with Verizon initially here a couple of weeks ago. And Wavelength is extending the cloud APIs, cloud SDKs, the cloud programming model from our AWS regions into the edge of mobile networks in order for our customers to use the same APIs, the programming model, the consumption model there at those low latencies with that high throughput, as Verband already mentioned, so that they can do what they weren't able to do before. I think we'll dive more into detail later, so I'll leave it at that. And
yes, we will.
I'll kick it over to you.
Thanks. Sanyogita, you're last.
Yeah, so Sanyogita Shamsundar, I'm at Verizon leading some of the technology innovation primarily from a product and edge perspective. So I've been at Verizon for about 10 years. I've started off on the device side, actually, when we were launching 4G. And then I spent several years on the network, what we call planning, working on the spectrum capacity, working in the early days of CBRS with the FCC, as well as millimeter wave type of spectrum availability, as well as driving a lot of the early LTE 4G innovations at Verizon. And then I led the 5G program in the early days, like about 5 years ago, we put together a consortium of partners to drive 5G standards, bring them up from a timing viewpoint. And I worked with the industry to essentially create specs for our fixed wireless, and then we drove that into 3GPP, as they call it, from a standardization perspective. More recently, I've been working more on what do we do with this 5G capabilities, what do we do with this edge in terms of creating more products and services with startups as well as larger partners like AWS, as Sebastian mentioned. As part of that, we do a lot of innovation collaboration in the 5G labs. That's kind of a venue where we do it's kind of a co-working space, incubator, physical labs, and so on. So we have a few of those locations that my team runs. Prior to Verizon, I was with a few startups, maybe not as successful as you, Verband and Sebastian and Mariam, but I am a sucker for innovation. So
nice, thank you very much. And as you can see, audience, you can see that we have amazing panelists here. So before we start diving deeper, very quick overview of the 5G ecosystem. We're not going to talk about the health aspects of 5G. Essentially, a 5G device is safe to use. Of course, it doesn't make sense to stand in front of an antenna for an entire day, but in general, it has the same implications of other wireless technologies. And we're not going to talk about that. We're instead going to focus on the technology, the costs, and the applications. You heard that 5G operates across 3 bands, low band, 700 megahertz, medium band, which is 2.5 to 3.5 gigahertz, which is very similar to Wi-Fi, and then high band, which is 24 gigahertz and above. And Mariam from Movandi will have a lot to say about that. There are several innovations in 5G, and Sanyogita touched about those very briefly. I took notes because there's so many, I didn't even manage to remember all of them. We have enhanced mobile broadband, ultra reliable low latency communications, massive MIMO, massive machine type communications, beamforming. I'm already confused, but we're gonna cover some of these and clarify some of these with you. We're also gonna talk about costs. In fact, there was a question from Alex Liang about costs. We're gonna cover those too. And what are the applications we can build beyond the hype? So Verban and Sebastian will tell us more about it. So you can see that this panel is actually very, very well assembled. I think we did a great job, but let's dive in. So let's go with the next question. And I will ask you panelists to maybe stick to maybe 1 minute in your answer because we're running a little bit behind schedule. So what is so interesting about these new technologies being introduced with 5G? Let's start with Sebastian.
Yeah, I think in my mind, what's most important, at least to me, is that it enables our customers to leverage not just lower latencies and a higher throughput, but reliably so lower latencies and a different quality of service than what was possible before with some technologies called network slicing and a few others. And the idea is that when our customers leverage that, in addition to wavelength or edge compute in general coming closer to end devices or distributed users, you can think of and build completely new immersive user experiences. You can now reliably offload processing from an end device onto the edge because of those capabilities, because of that quality of service, and because of that latency. And that combination of the cloud coming closer to you and the network improving throughput and latency and quality of service, and while I will dive into use cases more later, lets our customers do very interesting things and again, leverage that cloud consumption model too, where they don't have to invest in heavy equipment, where they don't have to have dedicated servers on site, or where they can leverage sort of the latest and greatest without having to patching, maintain, and support it all the time. And so that's what excites me the most, but I'll let the others answer in regards to what they think. For me, that is a key component of what 5G is all about.
Nice. Sanyogita?
Yeah, I think Sebastian did a great job talking about the capabilities that, the cloud being at the palm of the hands. That's how I think about 5G. Is like I have all the compute that is available in the cloud at a latency profile that as if I can depend on it from a reliability perspective that I can use that as the compute power that is available locally. And what that means is that you can think about building more complex applications that use many more dimensions of the data from the cloud into the end device. From a consumer viewpoint, if you look at it from an enterprise viewpoint, it has certain applications. But let me focus a little bit on the consumer viewpoint. You are talking about being able to have higher quality augmented reality type of applications. Augmented reality consumes a lot of bandwidth, and if you download it, it consumes space on the device. So it's limited in terms of the quality of experience today, and hence I think the utility of that is limited today. I would say you could do a lot more from a consumer viewpoint if you had that flexibility of doing a lot more on the cloud. And then that brings up other things like lighter weight devices and in the future and that type of stuff. Nice. On the enterprise side, if you look at cameras as an example, you can take a lot of green, especially in brownfield type of scenarios, use existing cameras, whether it maybe used for security, and start to think about using them for some other operational type of transformation type of applications. And so if you look at the total ROI of things like this, it starts to make sense because you can add applications and like services. Hey, is social distancing being observed, right? I could think about doing that incrementally.
Thank you very much. Let's hear from the two startups in the room. So Mariam and Verban.
I think my colleagues, both Sebastian and Santiago, they both basically explained this really well. Let me focus a little bit more on what actually enables all the stuff they're saying, which are fundamental, which is beamforming. I think these two elements basically allow us to go beyond what has been done in the past. They really enable support of multiple users, multiple devices, and simultaneously basically supporting condensed area while maintaining the fast data rates as well as consistent performance. And it takes a number of antenna elements to work together and separately to create a 3D beamforming, which can push the data and coverage the outer limits. So in massive MIMO, each element of a large antenna basically feeds transmit and receive separately, and they have a different feeds. And the more antennas, the more the possible signal paths, and the better the performance in terms of data rate and link reliability. These are things that were not before used extensively in the past generations. And beamforming focuses basically the transmit and receive beam into specific areas and increases the gain and avoid interference. So this is very essential in the millimeter wave spectrum, and that has where actually we get the highest available bandwidth and support the maximum throughput. And massive MIMO is great because it can support many tiny antennas.
Great, Verban, what do you say?
I think it's such a generational leap in technology, right? If we try to nail down the killer app for 5G, so-called, right? I think that's a futile effort to be able to guess that very well at this stage, right? But I came across something very interesting a few days ago, which is just, if you look at 4G and rural areas, right? What 4G couldn't do for rural areas, this is in the sub 6 gigahertz band, 5G is going to bridge that gap just in terms of bringing more people online. Just the very, the baseline goes up, and we all know the network effects of, the web and the community there, right? Bringing more people connected is just going to be immediately visible, immediate benefit of as more 5G comes online. And obviously, the applications that Sanjogita or Sebastian talked about, right, in terms of VR and some of the thin client possibilities there, they will come later, but it's pretty difficult to guess that right now.
Nice, thank you very much. So another question, let's talk about costs. I've read a study that estimates that you will need about 13 million stations in the high band, which is 24 gigahertz and above, as we mentioned, to connect 60% of the US population for a cost that is estimated to be in the ballpark of $400 billion, which is, kind of a lot of money. So is this going to happen? The answer is yes, of course, but where do we find this money? Who's going to invest in this? Maybe we'll hear from Sanjogita and Mariam about this. Sanjogita.
Yeah, so I think every generation of technology brings a different challenge, right? Even in the 4G days, when we started off building 4G, the model was more towards like 3G, big towers and deployments and so on. But as we started seeing the need for capacity, we started adding what are called small cells, which are lower power, smaller footprint, smaller profile, boxes that can go in sides of buildings and lampposts, right? So the architecture already had started changing on 4G, and then on 5G, I mean, especially on the millimeter wave 5G, the cost structure is a little different. I don't think we can go by the same assumptions that we had when we were building the network as we were building 10 years ago. And that's one of the important aspects that we all have to remember, right? That you need to be building technology that goes in at scale. And that's why, the things that Mariam mentioned are important. Some of the antenna work, the MIMO, the power consumption has to be lower because that's an added cost. The size of the box has to be much smaller, easier to deploy, like less than Wi-Fi. So I think, and then I don't know that you can use the same kind of analogy for coverage and so on. I think it's very like a millimeter wave when we talk about applications are targeting a slightly different type of application and service profile than the low band. So because 5G has defined it for all frequencies, you'll be able to use different frequency bands for different types of
yes, absolutely. Let's hear from Mariam. This is, at the center of your startup in a way. So tell us more about this.
Right, that's true. So, one thing is that even though 5G, especially millimeter wave, is completely new technology and different from the previous generations, as Santiago was mentioning, all the studies and everything that's applied to it for all the cost analysis, everything is the traditional model, which is, completely, it's not accurate. So in traditional model for deployment, you would have a macro cell, and then you keep adding more of them, and also small cells in order to increase the coverage. Now in millimeter wave, the signals get attenuated, and because of that, it's the cell has to shrink, and you need more small cells to be able to basically get the coverage, and that could turn out to be a massive deployment cost. There's no question about it, right? So. However, in millimeter wave, actually you have characteristics of that of millimeter wave that would allow for creative and innovative ways of deployments that could reduce the cost and also the time of deployment. And that's exactly what Movandi has been focusing on. So we're helping operators, private networks, and networking companies with our BMXR, smart repeater relay capable, which is also capable of networking and mesh networking in the future. And it can lower the cost while maintaining its latency, which is really critical. While other companies have been mainly focusing on trying to build, bulky, higher performance and higher cost solutions that can go into G-Node, via small cell and CP to overcome these challenges and adding more of them. We have not only been focusing on making low cost and high performing front-end modular solutions that can go into all these devices, but we have also developed a system, a beamforming low-cost system that does not add any latency to the path and can be easily installed on the street poles, roofs of the buildings, to extend the signal to the both in outdoor and bring the signal inside the building. These repeaters can be used to replace some of the high costly small cells and the fiber backbones of them, and reduce the capex by a lot. So we have built this based on our customized RFICs, antenna algorithm, and software, and they've been designed to basically address this issue. And based on our estimates, we should be able to help reduce the cost by 50% to.
Wow. That's a big reduction. And of course, when you reduce the cost that way, it gives a great opportunity for the market to grow and the ecosystem to build things around it. In fact, question for the other two panelists, Verban and Sebastian, let's assume, which is very likely going to be the case, that we're going to soon get a lot of bandwidth and a lot of stations to cover not just the US with 5G. What are the applications that are going to be built on top of it? Is it just about faster videos of dogs and other cute animals? Or, more seriously, is it fixed wireless access, broadband to the home? What other things are going to be built on top?
Yeah, hopefully it's the cute animals too, right? But no, I would say we see a bunch of interesting things on a high level to hopefully not take too much time. What I would say is I see again that offloading of processing from the end device, the cloud application coming closer to you, or the exchange of information between end devices that require some processing or filtering in between. So on a high level, right? What that means is we have, for example, a reference customer for wavelength already that is leveraging 5G and that is leveraging wavelength. And what they do is they enable doctors during their colonoscopies with advice to perform those at a higher reliability. So AI/ML models look at the video feed and alert the doctor of anything that might be worth checking out. And what they had to do in the past is they had to actually now bundle that with a server, because the device, as you might imagine, had to be lightweight. That has to be on premises, patched, maintained, supported. When more doctors wanted to sign up, it couldn't be automatically scaled, all sort of the typical problems that you have in that system. And what they were able to do is basically now offload that processing reliably and at low latency in a way that it's still user-friendly, and now can scale and doesn't require dramatic changes or hosting of data center type equipment in a hospital. And when it comes to, applications that come from the cloud closer to you, we all know, for example, game streaming is a big topic. Game streaming certainly works really well, enables lightweight devices, but when it comes to mobile networks, can be complicated because your request from a mobile device goes through a radio access network, the mobile network, through an internet exchange over the internet to a region. And sometimes that can induce latencies that aren't conducive to the type of mobile gaming that people want to experience. And so that's the kind of scenario where you say, well, now something that's already running in the cloud is coming closer to you, leveraging 5G networks. And then the last one, hopefully I'll make it quick enough, is that exchange of information between devices. So we have another customer that's a reference for wavelength, for example, that enables or is starting to enable the future of connected vehicles, and especially in a cellular fashion. And what's really interesting there is that you can exchange a lot of information between IoT devices, different vehicles, pedestrians, whatever it might be, but that information can be overwhelming. That information can be faulty. That information could be malicious if somebody took over a device. And so a neutral broker that can process with high capacity that information, filter it, apply models, make sure that information is reliable, and pass it on to the right vehicle at the right time, that's the kind of new and modern application and basically market that doesn't even exist yet today that can be enabled with these technologies. So that's what really excites me.
Yeah.
Typically, when you speak with somebody from AWS, you hear us talk a lot about our customers because we do the boring heavy lifting, but the customers do the really exciting stuff. And those are some of the use cases that I see that I think make it all more real, leveraging those technologies.
Absolutely. Verban.
I think the video application, right? If you look at the past 10 years, it has been the killer app for the web. The entire online commerce has centered around video. I mean, if you look at YouTube numbers, Netflix numbers, it speaks for itself. So that when 5G gets deployed, right, I think we will see video get another step up just in terms of consumption and the final polish on how video looks like on the web, right? That's the near term, right? And 2 minutes ago, I said, let's not speculate on what 5G can do for us, right? And I'm an entrepreneur and I can't help myself speculating. So to some of the stuff that Sebastian said, right? Imagine a completely thin client, right, in the palm of your hands, like a piece of glass, right, that replaces the phone. And Apple is not going to be very happy about what I'm going to say, but it's entirely possible that your phone becomes a cloud phone. Your identity lives in the cloud, and you just access it on very thin, lightweight devices. You're not installing and maintaining a heavy edge, super edge device, so to speak, right? And we're imagining applications like this when we build our platform, we plan features at Quadric, right? We are imagining that middle tier that Sebastian mentioned of a processing layer that's very close to the end consumer device, right? Before there's a hyperscale cloud serving into the application.
Nice.
So, that's just one possibility of a super thin client phone, but there's many more
Yes.
that sit all day and speculate on.
Thanks, Verban. For the audience, we are a little bit over halfway through the event, so I hope you're having fun and enjoying the conversation so far. I am. We have received some questions from Elisha, TJ, Unadkat, Alex Liang, Sam Haidari, Alex Morasegi, Francisco Lobera, Kavian, Barumand. Sorry if I butchered your names. I tried to pronounce them the best I could. I will pick one from Hamid Movahedi, principal engineer at Rivian. And I'm going to summarize it a little bit. The question is, driverless cars, delivery drones, do they need 5G? Will they benefit from 5G? Personally, I would be scared. This is not the question, this is my comment. If I'm driving in a driverless car, if I am in a driverless car, the car loses the signal, it stops, and a drone flying over me drops a bottle of wine on my windshield. Jokes apart, of course. I think that a driverless car, if we're going to have it and see one soon, will need to operate independently of network connection. Is that correct? Sebastian, what do you think?
I think at least for the time being, for sure, right? I don't want to overhype that everything will be offloaded immediately. It's what Verban kind of like, mentions is like, are we there yet? No, but can we think about it? Of course. I see it though, realistically starting already in a sense that with 5G and what I mentioned earlier, that example of exchanging information between cars and devices, you can at least enhance that that safety that a autonomous or connected car should provide. The idea is that a car can see through the cameras and through its sensors in its vicinity what's going on, right? So if you want to do that processing on the car to not rely on connectivity, sure. But if you can get messages from things around you that you can't see. So for example, typical CV2X use case, a car is parked on the right side of the street. You're passing that car might have a camera and might see that a bicyclist is running a red light. Wouldn't it be great if your autonomous car would be able to get that message through the broker at the mobile network edge that already does object detection, vector analysis, understands what's happening, can now feed that signal into your autonomous car and prevent even things that might otherwise be hard to prevent, right? So I would say, are we there where we're offloading everything from every device yet? No, right? I don't want to pretend that's the case. Yeah. But I do believe we can already leverage some of these things that will enhance that, and maybe ultimately make it cheaper for car manufacturers and doesn't have to have them invest in basically driving data centers, right? And so that's sort of the idea.
Sanjogita, what do you say?
Yeah, I think Sebastian did a great job there. I guess the only thing I would like to add is that when we talk about driverless cars, it is like another device on the network. and just like we need different edges, you do need local intelligence on the car. There are some things that you have to make a split-second decision, or even less than a millisecond or whatever, less than a human eye, really. I mean, a human eye is 100 milliseconds, believe it or not. It's a fairly long time, blink of an eye. So anyway, bottom line is you need processing. The question is, do you carry a data center along with you in the car, and thus add for the cost and the complexity of the car. Definitely a wide area network, a wider area local network is important for the use case that Sebastian mentioned. Today we use Waze to navigate. Tomorrow the automotive will need the wide area network to figure out routes and things like that, behind the scenes, and as well as like around corners and things like that, where the car-to-car communication is not going to be reliable. So there is a place for every single type of edge and network connectivity in that ecosystem. It's not like you'll be able to replace one or the other.
Thanks. And Mariam Verban, what do you want to share about it?
Okay, so this was covered pretty well by both Santiago and Sebastian, but let me just add this. I absolutely think that this will happen. And I really think that there are steps to getting to the ultimate self-driving car. We're not there yet. The first step is basically where we are, and we're trying to do, getting all this data that are coming from camera and sensors. There is and will be a brain center within the car that can basically get this information, processes, do AI, all the decision making. But that's not the safest. At the end of the day, you really have to have all the surrounding information of the other cars and environment. So you need to be able to transmit and transfer this data from the car to a brain center outside, where all this data from different cars are being received and processed and basically go back to the car. And that's where you actually get the ultimate self-driving, which is much safer, and it can only happen with 5G because that's the lowest latency and can support huge amount of data.
Yeah, from Quadric's standpoint, right? What we're building for, we'd love your couch to turn into a data center, right? That's putting that aside. It's not going to be all or nothing, right? So if we take an example of a driverless car, like what Sebastian said, you could use the 5G for information around, locality of traffic nearby, or traffic at the next intersection. That still comes to you pretty real time, right? And then the car is going to need its own edge compute, right, to avoid the super real time and those types of decisions, right? But if I move away from the driverless car, think about a factory robot, right? That could completely run on 5G with very little processing on board, right? You could have just a stack of sensors and stream everything up to the local data center in the factory, so to speak, right? And then process it all there. Definitely easier to build and deploy than a, compute on the robot, which takes time to build and ship, right? So the design cycles, the costs, everything would optimize if you could do that.
Nice. Thank you very much. I think it's now questions for this one for the startups in the room, and then the next one for the big companies in the room. Given that the time, we're at 10:40 a.m., just try to keep it maybe in around a minute. So the question for the startups in the room, Mariam, you, both of your companies, Mariam and Verban, are in Cota's portfolio, and I would have invited them anyway, I swear. Tell us how to build a startup in this specific sector of the industry. What are the challenges, the advantages, and also the market opportunity? Verban, you want to start?
I think you have the usual challenges, right, of a startup, which is getting a good understanding of the market, getting a good product market fit, having a huge lead on top of your competitors. Either they may be existing large corporations or other startups, right? Assuming you have all of that, right? Assuming you've cleared that, you have a product, you figure out the market. I think the most challenging aspect in selling into these types of markets is the sales cycles, right? And that directly conflict with a startup's core need. One of the core resources we have is cash, right? And so long sales cycles, because the spending here is coming from capital costs and capital deployment, right? Which have decision cycles, deployment cycles that are multi-year. That does not work very well from a startup standpoint, right? But given those sales cycles, right, what we try to make sure is whatever we're working on, whatever deal we're trying to close or spending a lot of time on, it better be worth it and not just, from a good revenue standpoint, but like a game changer, right? Every deal that we work on, if it goes through, it needs to be a game changer, right? The other advantage of the longer sales cycle is you can work on many deals at the same time, because these deals are can be spread out over time, because they're just decision making and evaluations take more time. So we use these, properties of long sales cycles. So again, we go after really meaningful, accounts, not just from a revenue standpoint for trying to change the game, and use the long sales cycles there to our benefit.
Thanks. Mariam, what about you? What about Movandi?
So let me say that, first, it's been a truly exciting experience. I mean, 5G is beginning to deploy rapidly. But in order to truly achieve all these ambitious goals of latency, bandwidth, etc., there are challenges, especially in the millimeter wave. And as you can see, these challenges are basically require real innovation and out-of-box thinking. So definitely not boring for people who love to solve problems like us. So that part of it has been really, really exciting. There have been challenges, as exist with every other startups, and because there are many, because there are not too many experts in this area of millimeter wave, and it's a new technology. At every level, like PCB design, antenna, module, everything is basically new, and it takes longer. And as a result, even the deployment is taking longer. And for the billions and tens of billions of dollars revenue growth that will definitely be there, it's going to take time for that to happen. So and we are actually doing something fundamental, right? We're helping to enable this market because it's a completely new technology, and that basically makes it a little bit more kind of challenging. The main challenge is because most of the financial investors are focused on very short-term revenue and something that they can make money quickly, again, not too much into fundamental breakthroughs that may take longer, which much higher upside. Luckily, we've had great investors and strategic partners, and that's helped a lot. And we've been able to develop amazing technology over the past few years. And basically, I think what we've done, I can honestly say, because I've managed both big and startups, and I can tell you that I am very proud of our team and what we have achieved so far.
Nice, thank you very much. Before we go to the other question for the two big companies in the room, we are receiving a lot of questions from the audience, and we will not be able to answer all of them. We'll answer one more. But for all of you out there asking questions, know that we are reading all of them, and we will try to follow up with you afterwards, given that we're unable to cover all of these questions in this limited time that we have. So Sebastian and Sanjogita, how's your experience in a large company, in your executive roles, managerial roles, in relation to the specific sector of 5G? Anything specific or different compared to another or more traditional managerial or executive role?
Well, I mean, if I may chime in real quick, keep it short. I think I'm looking at it from exactly the opposite end that Virban said, right? So the innovators that will build these solutions have constraints that they can't wait for things to evolve, and so taking something that is built for today's and yesterday's network and kind of making it seem like it can work better or whatever for something that's in the future is one of the challenges. I can't have it all fast enough to kind of get the products going, because customers are asking, well, when are we going to see all of this, right? So I think that is one of the challenges, and we are trying to do help with that by having fast track some of the testing, as well as make things available on a limited basis, because some of these developments do take a longer time. I mean, like Mariam said, like the chip design is a long process. And when we have a dependency on that entire supply chain, we have to. That's one of the bigger constraints.
Nice, thank you, Sebastian.
Yeah, I'll make it quick. I think I can just second what Sanjogita said. I think for us, from a cloud perspective, very egocentrically, but the unique wrinkle here is that we're dealing with a lot more physical device dependencies than we usually do, right? So anybody, that's kind of the promise of the cloud, that has a laptop and can be either in your mother's basement or in your house or in your car. If you have connectivity, you can build something in the cloud, you can try something, you can spin up resources, turn them down, only pay for what you use. In this case, what makes it all real is that latency, that performance, that user experience, right? And so you do need to have the right kind of devices, the coverage areas and so forth to see the difference. And so for us, it's all about how can we make that more real faster, just like Sanjogita said, right? So one of the things we're doing is wavelength zones are part of, for example, the Verizon network along with said other carriers, and you can attach to them through 4G or 5G devices. Already test out, what's the difference going back to the cloud versus edge compute. Obviously, you don't get the 5G benefits yet. We're thinking about, device programs and on, but, lots of detail. Not everybody might care, but that's sort of how I look at it, is that there is that dependency, which everybody said. And from our perspective, we really want to help just make that time period shorter. Like, I think that's sort of been resonating across the audience and the panelists is we think 5G is real. It's all about, and important, it's all about how quickly can we make it real? How quickly can we make it available to everybody, right? That's the biggest challenge, I think.
Yes, I agree. I think it's a great answer. We have, again, a lot more questions coming from the audience. So I'm going to pick one. And again, we're going to try to answer some of them afterwards. So bear with us. Actually, thank you for asking many questions. We didn't expect that many. We are over 20 questions being asked. And we have more than 150 attendees attending live this event. So thank you very much for being with us. And I really hope that this has been useful so far. We have 10 minutes left. So bear with us for another 10 minutes and then you're free to go. The question I'm picking is from Michael D'Onofrio, principal at Planet First Partners. And the question is, I'm again paraphrasing and summarizing it a little bit. How do you see 5G and edge computing working alongside or replacing traditional data centers? Let's go, 1 minute each. We can start with you, Sebastian, again.
That's a tricky question for me because I don't
I know.
traditional data center. I would say it complements each other really well, edge compute and AWS regions. So one thing that maybe not everybody will be familiar with, but when we talk about an AWS region, that's actually not a data center. That's a number of what we call availability zones that are on different power grids, connected to different ISP providers in different floodplains. And even availability zones themselves are clusters of data centers. And I'm only explaining this because there's a difference with edge compute, which you could look at as a data center, right? And so from our perspective, there's a very clear benefit in the kind of durability and availability you can have with the AWS services in a region, and then the individual data centers at the edge. And so we see a real benefit in doing certain things at the edge, processing, especially real-time processing there, but then maybe storing the data that you actually want to retain and do batch processing on later for insights long-term in a region where it might be more economical, where you will get different durability and availability. So I see it as a net new benefit and a complementary, right? And I'm not going to answer anything about traditional data centers. So I'll pass it on.
Nice. Sanyogita.
Similar thought. I think it's an alongside. It's not either or. And also, I think adding a little bit more when you're talking about on-prem stuff, right? When you start thinking about some of the tools that Mariam is talking about, and the announcement that we made in building 5G, the ability and the architecture of the 5G network, which allows for edge compute. So you can talk about terminating those edges at different points or along the transmission path or whatever data path. And depending on the application and the total cost TCO, you can think about breaking up different parts of your processing chain at different locations. So in that sense, I guess it's a either or not, and not neither, but really and from that perspective.
Nice. I have I think a quick comment before we hear from Mariam and Verban. I think this is one of the most interesting areas because we have edge computing and connectivity coming along, and 5G is of course the latest installation in a way, but there's also a very important effect on the applications being built and how these applications obtain, for example, resilience, durability, availability, etc., which was what Sebastian was mentioning earlier about, Amazon's data centers, etc. So this is a super interesting area in my view. And again, the question is about how is this going to replace or complement, I would say, data centers. So Mariam and Verban, what's your opinion about it?
So I agree with everyone else. I think edge could be an important solution for especially some applications, retail, banking, and other industries within dispersed service locations, the ones that need to process large amount of data in real time. Edge is not really going to kill data center, I don't think. And I really think that, as everyone else said, the customers are going to run hybrid solutions, combining traditional data center and applying edge for performance base. I think that's the way it's going to go.
Verban?
I'll make one subtle point here is that, completely agree on them being complementary, right? But from a services standpoint, it's going to generate more revenue for companies like Verizon and AWS, just more service they're offering that's going to be consumed more. But from infrastructure companies that are serving into data center equipment and technology there, this is a huge opportunity because we've done a lot of analysis. What we've learned is the edge data center is going to look very different from the hyperscale data center in the cloud. And it has different needs, like Sebastian said, latency and turnaround time and power needs, right? So that's the big opportunity of, we're starting down this path of a whole new class of data centers that are going to be built closer to edge devices. And that's what's the slight difference in terms of the subtle point that I wanted to make in terms of the opportunity there.
Nice. Thank you very much. So we are pretty much at the end. We have 6 minutes left. So let's just say some closing remarks, from each one of you. You have, let's say, 1 minute each to share whatever you think is needed to be shared that we didn't discuss during this particular panel. So Sebastian, you want to start? Go ahead.
Yeah, sure. I think everybody saw me carrying the flag, so I'll just say it one more time. Wavelength is live. I'm super excited to see customers try it and build things that we haven't even thought about yet. If you have interest, please let us know. First few wavelength zones are in the Bay Area and Boston. More are coming soon. Even internationally, we have a few coming. So my closing thought would be, I can't wait to see more and what our customers are going to be doing. And hopefully I'll have a little part in making that happen.
Nice. Sanyogita?
So echoing, right? I mean, this has been an interesting time for all of us, but I must say that we as Verizon have continued to move forward and in fact accelerate the deployments. I mean, though we have 30 plus cities already with 5G, ultra wideband, millimeter wave. Make sure we have the right flavor of 5G here, and we are on track to build 60 plus cities by the end of the year. So 5G is here. We have the MEC zones that Sebastian referred to. So we are, and then we have 17 plus stadiums, NFL stadiums with 5G. So there are many opportunities where we can come and test and build for Verizon from both consumer and enterprise perspective. So I'm excited about that, and I would welcome any more discussions on that.
Thanks, Mariam.
Okay, let me first say that I love to do more work with Verizon and Santiago on this whole thing. I agree with her. It's exciting to see Verizon actually going and aggressively trying to build that. And it's not just that. I think there are other operators who are also now coming up. But generally, 5G is going to be the next big thing and will create many new applications in all different areas, including telemedicine, automotive, AI-enabled applications where you actually have to need the high data and low latency to be able to basically do those kind of applications. 5G sub-6 will be bigger and faster in the beginning, mainly because it's simpler to basically build it, and it's for millimeter wave, the spectrum has not been assigned in all over the world. But that's not the real game changer. The real game changer is millimeter wave, where huge bandwidth can be allocated and huge amount of data can be transferred. In a few years, bandwidth in sub-6 will not be sufficient to support all the demand of the customer. And that's what we have been working on. We've been working with Verizon closely and other operators to basically enable this. And to the skeptics of millimeter wave, it reminds me of the skepticism we were hearing about inclusion of connectivity, Bluetooth, Wi-Fi into cell phones when we started that development. And look, I mean, that device is basically into every mobile devices right now.
I think Qualcomm will agree with you on that one. Verban, last one.
I think Sebastian and both Sanyogita, you guys touched on this before, what's happened, if you could find technologies before that sort of conflicted or cannibalized something that existed, and those tend to have difficult deployment because incentives aren't quite aligned, right? A large company has an existing revenue, there's this new thing, and they're conflicted on, well, am I going to lose this revenue if I go do this, right? This is not one of those things, right? This is totally complementary, which is why you see such, intensive effort, right? In like what Sanyogita said, building new chips, radios, things like that, and large and small companies coming together to pull this is because we have super aligned incentives to bring new capability to market, right? And with all these applications waiting to just leverage that infrastructure, it's amazing. And we're Quadric is in the middle of this, and we'd love to talk. If you want to, please feel free to reach out to me, and we'd love to talk more.
Nice, thank you very much. So some closing remarks for just 1 minute, so stay with us for a little bit more. The panel is ending now. I want to thank the panelists for having been with us and having been so gracious with their time. I hope you attendees enjoyed this panel on 5G and cloud computing. We will share the recording later, so it will be made available and you can share it with your friends and other coworkers. We will try to give you some contact details for the panelists, if that's possible. Also, this is, as a reminder, Cota Access, a recurring event that Cota Capital is doing. And we're going to have our next one on November 19th. So stay tuned. You will receive news about that. And now I need to show you a disclaimer page, which we're required to do. That's the end for us for today. Thank you very much, and see you next time. Thank you, panelists. See you next time.
Thank you, everyone.
Thanks.
Bye.